Today we're going to talk about compound inequalities, and if you've used compound inequalities in English, I hope that you know it's two sentences joined with a conjunction, and some of those conjunctions you can use are and or, and in math we're going to use compound inequalities with and or, and today we're going to focus on the and. So a compound inequality with and is true only if both inequalities are true, and we will refer to it as the intersection of the two, so where they overlap or intersect. So when we're doing our work today, we're going to graph the two parts below the number line and then the solution above. And I want you to do that when you do your homework also, so we're all consistent and we'll be able to tell where the solutions are. So think of all numbers that are less than 3. So is 3 less than 3? No, so it's an open circle, but all numbers less than 3 would be going this direction. And think of all numbers that are greater than or equal to negative 2. Well, negative 2 is greater than or equal to negative 2, so it's part of the solution. So we have a colored in dot there, and then all numbers greater than that would be going this way. So we want to find numbers that make both these inequalities true. So they would be where the two graphs intersect, so it would be this area down in here. So we're going to graph the solution. Is negative 2 in both of them? Yes, it is, so it needs a colored in dot above negative 2. Maybe if I can get it there. And then is 3 in both of them? No, it's in the bottom one, not the top one, so it's an open circle, but all points in between are included in the solution, so you connect them with a line. So this is going to be your solution on top. If you have a compound inequality like this, the first thing you need to do is break it down into its two parts. So its two parts would be negative 5 is less than x minus 4, and, so write the word in between or the symbol for and, x minus 4 is less than 2. So we first need to solve each, and remember now we can write out to the side, we're going to add 4 on each side. So you would get negative 1 is less than x. Probably a good idea to turn it around, x is greater than negative 1, or at least make sure you read it from the x when we get ready to graph it. Over here, if we add 4 to each side, we're going to get x is less than 6. So we want to graph the two parts below the number line and the solution above. So make your number line. Greater than negative 1. Negative 1 is not included. Line going to the right. Less than 6. 6 is not included. And all numbers less like that. So where do they intersect? Well, all numbers between negative 1 and 6. So an open circle on negative 1, open circle on 6, and a line connecting them. So it would look like that. In number 3, we want to subtract 3 from each side. So we're going to get 3 is less than w, which again is the same as w greater than 3. Over here, when we subtract 3, we're going to get w is less than 8. So we need to graph this. Greater than 3. Less than 8. 3 and 8 are not included, so we need open circles on both ones, and there it is. So again, for this problem, we need to break it down into the two parts. 7 is less than x plus 2, and x plus 2 is less than or equal to 11. So to solve this one, we need to subtract 2 from each side. We get 5 is less than x. Reading from the x, remember, that's x greater than 5. Over here, when we subtract 2, x less than or equal to 9. So again, make our number line. Again, I don't care if you start from 0, just so you have some numbers on either side of what we're doing. So greater than 5 does not include 5, but all numbers going to the right. Less than or equal to 9 includes 9, so we need a colored in dot where 9 should be. And then go in this direction. So where do they intersect? 5 is only in one of them, so it's an open circle. Up to 9. 9 is included in both of them, so it's a colored in dot. And our last one here, don't have to solve for anything, it's already solved, so all we need to do is graph it. And I want to show you the graphs can look differently, that's why we're doing this one. So less than 4, open circle on 4 going this direction, less than -2. And again, we want to do an intersection of the two, so where do the two overlap? Well, they only overlap down in this area, so -2 and smaller, so it would look like that.